So here we are, I'm going to try and do a teardown. So first thing of all, with handles like this, a lot of these just have a position where the handles will come out and then you just pull. So they've got a kind of a locking cam in there, and then there's only one position where that cam will actually come out, and then you can see the various positions the handles can be stowed in. These are these little rubber bumpers that, as you can see, that they're very nice and squishy, though it looks like they're not using them to cover up any screws, so I'll just leave them on. There we are. So, I might actually leave the handle off. So here's the Siglent. It doesn't say warranty void, but that's, you know, what it's for, obviously. Siglent is fancy. They're actually branded. It's Siglent branded with their little logo on it and everything. So let's see. This is very thin. It's thinner than the one on the. Well, actually, I can just go like that. There we are. So now. Carefully cut through there like that. That almost turned into a problem. It looks like actually some of the aluminizing kind of peeled off at the corner where they forced it into that groove. So that's obviously how they actually void it, which is that when you lift the sticker, the chrome stuff, the hologram stays there, and they can tell it's been opened. Anyways, I'll just go like that. So now I'm betting these two screws are what really hold the unit together. Most of these, this particular form factor, the box just slips over. So we will. Ooh, nice. So that is a machine threaded screw going into an insert and/or metal, which I approve of. Any of the things where they thread into plastic is always kind of like, janky. So those two screws are out, and then this part of the housing pops off, and you can see it has little rubber feeties on it. So now this should slide off, though I expect I have to remove this screw. Yep. Not bad at all. 3 screws to get into the interior. It's designed to be partially repaired, at least. So, there we are. This is quite nice looking internally. Cursory inspection shows no bodges. Just put it on a piece of paper towel. Nah, don't bother. So here is our internals. You can see we have a very nicely divided system. You've got power supply and all the logic and the outputs. Big ribbon cable going to the front panel. Here are the BNCs on the rear, which are nice solid metal BNCs soldered down to 2 little circuit boards with ribbon cables. You can see you've got a little fan over here. 0.15 amps, 12 volts DC. Very nicely laid out board. Cool. So, and then on the bottom there's actually a little opening. I don't know why. Also of interest is the fact that it looks like they have an option to mount a fan on the other side. I wonder if this is a standard housing. And you can actually see down in here, you have 2 amusing jumper leads, and then you have a genuine clicky power button that presumably disconnects power completely from the entire system. So I would be pretty confident that this probably has 0 power draw when the system's unplugged. Other stuff of interest, you've got your little round binding post. Oh, that's amazing. Oops. GPIB, and then for some other interface. So you've got, you know, so it looks like this case can have multiple things. Like you can see how the light's shining through, and then they just cover them with this rear sticker. USB. Oh wow, look at that. They have gooped down. That's kind of asshole-ish of them. They've gooped down the retention clips for this cable connector. What the hell? Anyways, let me swap lenses and we'll take a closer look. So here we are looking at the interior. So there's a lattice. Let me actually... That's better. So you can see we have a lattice. Presumably that's a CPLD or an FPGA. Does lattice make FPGAs? Over here we have an Analog Devices black fin, which seems to be kind of the part everyone likes for test equipment, ADSP BF531, with some, I would bet that that's SRAM right there, and that's flash. So we have Hynix H57V1262 GTR 75C, and there's some Spansion S29GL064N90FT104. So that's almost definitely the flash for the micro. And there's a Spartan. So that's interesting. So there's a lattice. Okay, so it looks like from these the traces here. I gotta put something under this so that I can. Let me refocus 1 second. So that lattice device may not be a CPLD, it may be like a display driver, because that's certainly running into this cable which runs through the display. And you can also see that they've gooped down the two, the ejectors, which is kind of annoying. Got a little device over there. I don't know what that is, but it's probably power. And then there's one of these devices. Does anyone know this chip logo? I'm not familiar with it, but I've seen this. They had a similar device in the Regal scope with the same logo. I think it may be a support device for this or something. Also of interest is, look at this. It's labeled card. It's another FSC connector. There's a 1117. Oh, hey, look at that. Woo, ongoing camera issue. So over here we have two Burr Brown DAC 904s. And I've looked them up. They are 14-bit, 165 megasample per second digital to analog converters. So this is actually a 14-bit system, not a 12-bit. And then we also have some very interesting connectors. Look down there. There is TMI, TDO, or TMS, T-clock, ground, and VCC, presumably for the FPGA. So well, yeah, of course, FPGA JTAG. And then over here we have CPLD. So, and then if you look down in this corner, we have DSP JTAG. And then there's actually a little connector down there labeled UART. So this thing may be extremely hackable. I mean, you've got, JTAG, UART, like there you go, you see VCC 1.2. That's nice of them to label that stuff. I wonder what card was. And you can see this big connector labeled card. Oh, I think I know what this is. I'm pretty confident. I bet that's a USB host device, because this is running to the front panel USB. And presumably you have there RV1 and RV2. I'm pretty sure those are protection diodes. So I bet this, whatever it is, 1763A7806N. Actually, 1 second, I'll just look it up right now. 1763. I actually don't know who makes that. 7806, because that's a regulator number. But yeah, whatever this is, I bet it's a USB host device from the placement. And you can see it also looks like it's parallel bus into whatever card was. So over here we have the two DACs. And what is that? A D8580 from TI. So I bet somewhere over here is another DAC used for the offsets. And there's ADCMP, another Burr Brown device. Anyways, so over here is the analog section, and you can see it's very nicely done. Here's another ADC MP. So you can see you've got lots and lots and lots of relays, and then those are presumably part of the 50 ohm series output resistors. That's actually interesting. Look at that. It's a series parallel network, which is going to give you 50 ohms, but at a much higher wattage. I only see one of those. I wonder what that is for. Maybe the other one's on the bottom side of the board. No. Anyway, sorry about that. So your whole analog section is done with 74HC4D51s. There's an ADCMP device. Who makes these devices? I mean, I'm pretty sure that is Intersil, isn't it? 28210. But a lot of these things, what is that manufacturer logo? I'm not familiar with it. There's another I part. They're Japanese relays, which is quite nice. Here's a 17, what is it? It's a VCA 822. That's an interesting part number. VCA 822. So that is a variable gain amplifier. So this is it's a VGA. So this is presumably some of the however they're doing the fine graduation. So I bet this is a to D running the VGA, because this is a it's not a PGA, it's a VGA. So you need an analog input for it. More stuff. VCA 822, another one. 51661. Yeah, so the gain on the VGA 5822 is programmed with an analog voltage, so they're going to need a lot of DAC channels in here to run a lot of this jazz. 51661, nothing. So I think these are probably Chinese op amps by somebody. B149. Yeah, nothing for that either. I'll look around afterwards and see. I maybe edit something into the video. But 234607, I think. Those are hard to read. So there's your main DAC, and you can see that here's one and here's the other, and you can see that they're all parallel bused into this Spartan XC6. So it's a Spartan 6 FPGA. It'll diode FPGA run. Looks like that's almost been hand reworked. 12 megahertz crystal. So this is the thing that I'm pretty confident is the USB front end, particularly since I bet that's like an EEPROM for it. And you can also see it's got a 12 megahertz crystal, which would definitely be USB related. Bunch of little SOT23 devices. That's kind of interesting. Look at that. That is a bridge rectifier, I think. Try and get some better light on it. Or an isolator, Cosmo Y214S. Oh, what do you know? This is a that's a solid state relay. I wonder what they're doing with it. Maybe switching. Here's another 50 ohm resistor. So it looks like they've got like a big parallel series array for one of the channels and only a single big resistor for the other channel. That's kind of strange. But you can see you've got, stuff on the output, and then actually a bunch of 0 ohm stuff going on over here. I wonder if some of the stuff is populated differently for the different frequency versions. Like they may have some interesting filter stuff they can put in here, lead and some various compensation networks for the higher frequency versions, because I believe they also make a 25 megahertz. Well, I know they make a 5 and a 10 megahertz and a 25 megahertz, and I wouldn't surprise me if they also make a 50 megahertz version. So I bet some of this stuff is stuffed for the 50 megahertz version. But like looking at this footprint, I'm not sure. It's a so yeah, this is a yes. Okay, so this is the footprint of a single op amp. So you can see you have negative, positive inputs. So this is set up in a non-inverting, and then you can see here we have a resistor to ground, and then over here we have a resistor to the output, I think. The output should be right here, and I don't know where that runs. It's an interesting circuit, and it's kind of weird. One of the nice things you can see is that they've got a lot of various trace lengths, or excuse me, widths. So they've definitely put some energy into the layout here. You know, you can see here we have, yeah. So these are all single op amps. It looks like. So you can see you've got, here's your input signal. This is, let's see. So yeah, so you have a series resistor, and then you have a resistor in the feedback loop. So this is and this is going to be an inverting topology, and then you can see here that they can. It looks like they can do some weird jazz with the. They can hook it up a whole variety of ways. So they can also turn this. What the hell? So they can also, you know, if they don't stuff this part, they can stuff this part and this part, or no, this part and. Yeah, weird. They can hook it up in an inverting or a non-inverting topology. That's weird. And you can also see they've got, like, you know, a couple different part sizes. Look at the weird solder mask on that. You know, lots more parts. VCA 822. Here's another amplifier. There's one of those AD. I can't really read the part number on that part. Let me try coming at it from a different angle. Two, 3, 4, 6, 0, 7, 1. It's my analog devices. Oh yeah. Let's see if I can't kind of change the lighting. Oh yeah. Oops. Oh, that's good. 2, 3, 4, 6, 0, 7, 1. ADCMP 562 ER. See if I can't find that. Dual high-speed PECL comparators. That's a comparator. So that's a high-speed ECL comparator. That's trippy. I wonder what they're doing with that. They've got to have some DAC channels for offset, unless they're doing it all using the main DAC. In which case, that's kind of strange. Maybe there's some I2C DACs in here somewhere that I haven't seen yet. I don't see any. There's a TLO72, really? That's like the cheapest op amp in the world. Well, not quite. That's just a cheapo dual 28210 FBZ. Oh, I see. ISL 282010. Precision low noise JFET amplifier. I didn't know Intersil even made op amps. What the hell? Yeah, so these are also op amps, but these are dual. So you can see here, this is set up. You know, so you have, you know, output negative, positive. So this is a unity gain with compensation in the unity gain. That's weird. Yeah, so it looks like these are also op amps. So this whole area here is just, there's probably like 30 or 40. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's about 13 or 14 separate op amp devices in here. That's pretty crazy. There's these high-speed comparators, you know, but I don't know what these are. Though the topology really doesn't look like it can be anything other than an op amp. You've got power, these two pins are not connected to input, and then output's going to be that lead. Yeah, so I mean there's, yeah, it's an op amp, but I don't know who makes it. I don't know that chip logo. Some interesting oddments, the little transistor here. I wonder if they're using these transistors to switch the relays. It kind of looks like it. That could be what a lot of this stuff is. So I wonder, it seems like, okay, yeah, there's a lot of parallel traces on the bottom of the board. Also some other interesting stuff is, like, if you look over here, here's by the Spartan, there's a big footprint over here for presumably RAM of some sort. You can see a lot of the trace length equalization that isn't populated. I wonder if there's other options for more memory. 256 BGA. There's that CPLD pinout. There's that weird 28061763A. I don't know who makes that. That's pretty funny. Look at that LCD on. So then the other thing of it, the other area of interest is the power supply, which is quite nice. You can see over here. So here's the so there's the output section, and you can see we've got lots of capacitors and lots of diodes, and the whole thing is heavily coated in elastomer. And actually, there's a Clc filter here because you got a capacitor, and then these are inductors. So it looks like every single output rail here is going through a pi filter. It looks like it's got 4 rails, you know, because it's blue, black, yellow, red, black, white. Anyways, over in the power supply itself, we've got power transformer. There's going to be the switching device. So there's the controller, which is an NXP N7, anyway, TEA1610. Presumably just like an integrated switch mode controller. There's our bridge rectifier. Again, we have nice labeling, and there's actually, if you look down there, you can see that they've trenched slots. That's interesting. So this is marked L3, so that's just a really big inductor. Yeah, 90 watt resonant switch mode power supply with TEA1610. So it's a resonant switch mode power supply. You can see we've got some really big chunky ceramic caps, lots of vias. This is just a big inductor. That's kind of intriguing. Here's the main power supply cap. It is 400 volts, 220 mics, made by Rubicon, so brand name. Over here we've got common mode inductor, you know, typical, you know, input filter stage. This is nice. Look here, we have a nice strain up, you know, glass bodied fuse with a nice plastic cover over it in a fuse holder. Let me switch lenses 1 second. So here we are back. You can kind of see the overview. Big power transformer. Wouldn't surprise me if they're half-wave bridge driving this. There's your controller. Here's the filter stage. There's that little switcher. Big Rubicon cap held down with elastomer. Here's the input stage. You can see that 2 of the IEC terminals are soldered down to the board. The third one comes up through this lead and goes right onto a big frame ground right here, and that's a snug connection there. I wouldn't worry about that. Yeah, you can see some of these just enormous, like 2516 capacitors, and then there's some epoxy blob caps too. You know, there's a big resistor probably for current sensing in the transformer. That is 68 ohms. I don't know what they're doing with that. Oh yeah, it's probably current sensing because it's high voltage. This is that big inductor. That's an inductor, not a transformer. Here's the output transformer. You've got your Z caps across the Y caps across your transformer, and then you can see here we have, because the switch is over here, they've just got a wire jumper running from here on the board to there on the board, and then here's the big clicky power switch that actually looks like it engages and disengages the entire power. And one of the things you might be able to see in there is a big trace cut all the way along there to give them good creepage. Sorry, I need more light in here, I guess. Blah. Go away, you. So then you can also see it looks like there's a space for another fan to be mounted. So here's the overall structure. You can see D to A's, Spartan device, interesting chip footprint that's not populated. There's the beeper. There's that mysterious card interface. You can see you've got CPLD JTAG or CPLD configuration, FPGA JTAG. Yeah, so then further, you know, down here there's the JTAG. You know, here's this interesting UART port, and then you have JTAG for the black fin device, beeper, 1.2 volt regulator, stuff like that. You know, interesting. A little bit of support logic, presumably for these inputs. So I bet these are comparators of some sort. There's some more big 49 ohm resistors down here, presumably for terminating the input signals. That may be switchable. This is fairly interesting. You can see there's a big box here labeled U107 that looks like it was some sort of DC to DC or something that's not populated on this unit. USB device port right here. And then on the bottom side, well, first of all, you can kind of see this is the little ribbon cable that runs over into the front panel over here for the front USB, because that's the only thing over here. And then over here, well, that's interesting. Look at that. There's kind of like, look at that. It's welded. Kind of messily welded, but welded nevertheless. You can also see that the BNCs they use, this is like a solid chunk of metal. You know, it's the same for these BNCs on the back. These are really big, really solid BNCs. I wouldn't worry about them breaking. And then on the bottom there's this kind of amusing little access window. You can see a little heat sinking. So this has to be at least a 4-layer board, because I don't see anywhere near enough traces. You can kind of see they've got some power routing. A few little odd things. I mean, if I was doing this, I would probably have blocked this plane here so that didn't fill, but whatever. Yeah, it's a very nice board. They've got nice, you know, a lot of attention done to power routing. You know, multiple vias to bring across layers, you know. Lots of different sizes of capacitors. We kind of have big 0805s. I think smaller, you know, 805s, you know, different capacitor sizes for various stuff. This right here is the underside of the FPGA. Right here. And then the DACs, I think that might actually be under the DACs. Well, anyways, I think the DACs are located right here and here, so this is presumably decoupling for the DACs. Interesting, a few little unpopulated footprints. Here's more trace length equalization jazz going on under the, where I think that extra SRAM goes. Sticker with my serial number, so now Siglent can say they won't give me a warranty because they've seen my video on YouTube. Yeah. That's my iPad. I'm needing to look up part numbers. Anyways, so putting it back together. This just slips over the housing. Like so. And you can see that here's the grill for the fan. Did I put this on backwards? What is it? Why is it feeling kind of stiff? What's going on? Well, maybe not. It's just snug. Oh yeah, that's another interesting little detail I noticed. So that these holes are for the connector to poke in. Caught on something? There's nothing back there for it to catch on. Oh, whoops, that's the power switch. I'm like, what is that crackling noise? Oh god, I broke it. It's like, nope, I'm just turning it on and off. Get that light out of the way. I'll leave it on. Just put the 3 screws back in. So here you can see the fact that apparently it's good for running on airplanes. 100 to 127 volts, 45 to 440 hertz. Moment of truth. So here's the boot screen, incidentally. Siglent SDG1020. It's a Y. Cool. So there you go. If you have any questions, feel free to ask in the comments.